Okay, what's going on, y'all? Today we're gonna work through. Which one? Yeah, today we're gonna work through Ethernaut Hardhat. Sorry, Ethernaut level 9 with Hardhat. I'm just trying to get everything set up and make sure my audio is working correctly before I jump in. All right, we're good. So when we last left off, we did the vault challenge, and basically, actually, what did all that entail? Um, Yeah, so in this challenge, we learned how to get the storage of a a storage slot, and pretty much see if we can see that information that's at this storage slot. So the idea here was, even though this is a private password, because it's stored on chain, you can still have access to that. So we were able to unlock the vault and successfully complete the challenge. Um, yeah, so now what we're going to do is work through the King Challenge. I have to do a few things to get set up, but first let me go ahead and get an instance and then we'll jump into this challenge. And get everything set up on VS Code. Let's come here. Well, let's see. All right, let's change this. Get branch King. Okay. I don't know if it's going to be an externally owned account attack or a contract attack, but let's just turn these all into templates. Okay. Few things first is we want to okay. A few things first. Let's go ahead and copy this down into a king contract. So here, that's king. And then we're going to rename this to king.sol. And then we have to do one more thing. We have to, well, all right. So let's take a look at some requirements first. Well, yeah, let's take a look at some requirements first. So this contract below represents a very simple game. Whoever sends it an amount either that is larger than the current prize becomes the new king. On such an event, the overthrown king gets paid the new prize, making a bit of ether in the process, as Ponzi as it gets. Such a fun game. Your goal is to break it. When you submit the instance back to the level is going to reclaim kingship. You beat the level if you can avoid such self-proclamation. Okay. Okay, so I think with the prevent, we have to prevent the contract from claiming this contract or claiming ownership or kingsmanship. So let's take a look at this contract, and evaluate this. So We have an address king, which is going to be the winner, it looks like. You have a prize and then an owner. Okay, so the owner is going to be the message sender, king's message sender, prize is message value. Message value greater than good prize. Okay. So here, the value sent to this contract. So remember with the receive function, there's two special functions. There's receive and fallback. And in the receive, if you send money without any data, then you invoke this receive function. So we have message value greater than equal to prize, or the message sender is equal to the owner. Okay, so that's something I can never become, but I can make this message value be greater than prize. So we can do that if we send whatever this prize value is. And then okay, so then it's going to transfer the money sent in to this king. All right, and the new king is going to be equal to message sender. All right. The prize is going to be message value. All right, so I think the vulnerability is here. This kind of gives me a tip. So, let me tell you. Well, we know that this is going to be So what we can do here is prevent this transfer from executing. I think that's what the vulnerability is. How we do that is we need a contract with no receive. Because if you remember, if we don't have a receive function, or so let's say this. So for example, if we have an externally owned account, this transfer should always succeed if you're transferring value to an externally owned account. Now, if you use a contract and you are able to prevent this from executing, then you would pretty much pass this challenge. And the idea is when you use a contract, you can determine how it receives ETH. So if you have a receive function on it, then it will take in the money. It will take in that message value. If you don't have a receive function, then you're going to have an issue. So let us just so let's test it. So for an attack, we're gonna import the king.sol, and we're gonna uncomment all of this stuff here. Okay, I don't need this. I don't need any of this right here. And we definitely don't want this receive function here. Okay. We're going to use a king, and then call this king contract. King contract is going to be equal to a type of king. Yes, and it should be payable. Because we're going to send some value to this address. All right, so attack is going to be equal to, so here's the thing. We're going to attack the king contract. So let's say king contract dot call. And what we're going to send is message.value. This may or may not be it, but and let's see if we can see how to call a contract. Let's try something. Okay, so let's see. How do we convert a contract address? Okay. So it works like this. And then we need to make it payable, I thought. Okay, I gotta do one more nestedness. So let's make this payable. There we go. And I believe here return value not used. Let's say success. And I think the other one is just the bytes, but we don't need to use that data. Bool says. Honestly, I think we just leave the comma empty. That's not used. And let's just require success. I'm going to say call failed. Okay. So when we make a call to this address and send that value, the receive function should get that. Yep. And what I'm going to do to test this is just try to send money to my own contract. So what we're going to do is deploy this. Yeah, I'm going to deploy this contract and just try to send money to it and just test and see if money can be sent to it. And if not, then we know this attack should work. But obviously we don't know if this call is right. I'm pretty sure that this is how we can call this receive function. But yeah, we just have to see. So let's go to our contract attack template. We're going to rename it to force, or sorry, king. We want a king contract. We want an attacker contract address. We don't really care about balance, but we can leave it up. So the contract address here is instance address. We want to get this. Okay, we're going to deploy our own. So I already have this contract factory set up. Get contract factory, yep. And we're going to deploy, so this is going to be the argument that we deploy our attacker contract with. Make sure it's deployed. Okay, now let's also grab our king contract. Actually, I don't want to display that. So we have our king contract. And before we get any further, let's go ahead and do our attack flow. So first, we want to send. Actually, I'm not even going to send a test either to my contract. Let's just run the attack. Let's just go from scratch and see and go from there. That's a better approach, is to try to commit the attack and then see where we made mistakes. So send a message to, invoke the attack function with a message value greater than the prize. Yeah. Greater than the prize. So what we're going to do, actually, I'm going to check out and see what this prize is, but we may be able to just do it from here. I was given an array, but I'd rather look at this. We'll look at it here and determine that prize. Ooh, is it greater than or equal to? Okay, so it can be equal to the prize. Okay, so let us grab that prize first. Grab the prize data. Second thing we're going to do is send an attack or invoke our attack function with the prize value. The next thing we're going to do actually, that should be the end of the exploit. Yeah, that should be the end of the exploit, honestly. Let's do that here. And what we want to do is check if our contract is the new king. So for 4, let us grab the new king address. And if our contract is a new king, we know that our exploit should be right because we are the king now. And then when we go to submit the challenge, it should not be able to transfer to us. But I wonder if we can just test that ourselves. Maybe. So if we expect await attacker dot send let's say transfer so if we await attacker and we want the address to be contract address, and let's just send let's just send prize.toString. And we're going to expect this, expect this to throw. What's this mean? I wonder if we can just expect to revert. To be rejected is 1. I have to charge my laptop real quick. Okay. They have rejected on here? No, they have reverted. Alright, I won't do reverted. I'll just do, or sorry, I won't do rejected. I'll do reverted. So let's just go ahead and try to do this attack. Grab the prize data. So let's put prize in here too. We're gonna say we're gonna say prize is equal to, I don't think I can two-string whatever it is. I think this might be a big number, but actually let's see. Let's just test all this. Alright, so first off, let's comment this out for a second. And let's also comment out a few things. I don't want to really deploy this contract, right? We don't want to do that right now. Prize is going to be equal to king contract dot prize. As a matter of fact, let's make sure this compiles so we have all the artifact data. Alright, so we're going to get the prize, and let's just do prize type is type of prize. We might as well go ahead and print out the prize amount is price. Okay. Let's do that. So we're going to deploy this, or not deploy it, but we're going to just run this script. No. Test. And we're going to do contract attack king. We want to do it on network Sepolia. All right. And what we're going to see is a few things. We're going to see this prize. So we're going to look at this prize data here because this is public. And we can call this as a function. And then we're also going to see what type that is. And this is going to help when constructing our attack contract. So let's run that. All right, so it's an object. Oh, well, we have to wait because we're making a call to the contract. So it's a number, it's a big number. Don't know why. I don't know why that. Okay. So it's a big number. We get that value here. So, and we know it's this much ETH. 2, 3, 4. So I think it's like 0.0001 ETH. So we have to first convert that to ETH. So okay, I was able to use ethers to convert back to readable. Okay, so let's do this. Let's just test it. Price as it's going to be equal to ethers utils dot format ether. And we're going to turn this into prize. See what we get here. .001. Okay, perfect. So we're going to want to pass in, I guess another good thing to do is just see type of, I'm pretty sure it's already a string, but we can just say type of, see what we get. String, okay. So yeah, so this is the number we want. And that's the number we're going to pass in when we send this message value to the, when we send ether to the contract, we're going to use this. And honestly, I kind of want to add one to it, but this should work. Price value in ETH. Yeah. Okay. So we're grabbing the price data. we already know how to do that. Let's uncomment this, or wait, a few things. Kind of want to deploy a test Actually, let's do it. Let's deploy this attack contract. And let's see if our contract rejects it. That's going to be the next step for our test. So we can go ahead and do that. I can waste the gas for this. So we're going to deploy this contract. We're going to make sure it's deployed. And what we're going to do is end this piece right here. What'd I do? We're going to send send it to attacker contract dot address. And we're going to put prize value in ETH because we already have it. So it's going to should send exactly 0.001. And I'm going to do less than that. We do that. Okay. So let's just check to see if this is reverted. Just a test. Okay. Why is... Okay. So I just realized there's something wrong with my stream, and you cannot see what I'm doing this whole time. How can I refresh this? For some odd reason, it's like locked on the wrong screen capture. Yeah, I think I'm having issues with my my screen capture software. Um, yeah, whenever I post the video, I'm just gonna have to edit what happened, but okay. All right, so y'all can see that. I don't know why it was showing the wrong thing, but when I post a video, I'll redo it. So, all right, so if you're tuning into the video, um, we're working on the King contract on Ethernaut. Um, the purpose of this challenge is to essentially prevent anyone else from becoming the new king. So we have a few things. We have a king address, we have a prize pool or a prize, and then we have an owner of the contract. And the idea is we want to become the king of this contract and prevent anyone else from becoming the new king. And this is essentially a typical Ponzi scheme contract where the person who deposits the most money will receive the previous deposit's prize. So how it works is you send money to this contract. If you are the owner or you send ethers that's greater than the prize, you become the new king and you get paid the message value of what you sent. So table king.transfer. Yes, you get paid the message value of what you sent. Then next, you become the king, and then the prize. This becomes the new prize. So that's how this contract works. Whenever you go to submit it, Ethernaut is going to try to proclaim kingship. So they're going to try to become the new king. And while they are the owner and they can easily call this receive function, this should reject because the current king in standing will essentially deny this transaction. And that's what I'm working on right now. I'm going to try to create a king that's not going to be able to accept ethers. So right now we're testing out this theory. We set up a quick attack deploy script. So we are going to first so first I'm going to deploy a contract and just make sure that that reverts every time I try to send it some money. So we're going to run this script here. And it looks like it didn't work. No, so it didn't work. So this did not work. Confirm exploit did not work. Okay. So I'm probably losing money because I'm over here deploying a contract, but let's say gas limit. And I don't know why I have to do this every single time, but I have to do a manual gas limit here. And usually this helps pass it, but let's see. So right now it's deploying a contract. Oh. Insufficient funds. I should have 0.001 ETH, so that shouldn't be a problem. So I didn't have enough funds for the transaction costs. So let's do something for a second. Let's view on Etherscan and see if we could figure out this issue. So it doesn't show that transaction actually occurring. Exceeds block gas limit. Exceeds block gas limit. Interesting. So I'm able to create the contract. That's all good. Maybe that's it. Maybe I had the gas limit too high. All right. So we should have successfully had a rejected transaction. So let's go back here. Contract creation. Not sure why I didn't show the transaction. Oh, okay, here we go. So yes, transfer 0.01 ETH was and execution reverted. All right. So that's what we need. We know that we cannot send ethers to our contract, right? So this is a good like proof of concept that our exploit should work. Hold up. One of the homies just texted me. Yeah. Okay. So yeah, we know that this is gonna fail, and so we don't need to test this anymore, honestly, because we know it's gonna fail now. So we know that that piece works. But let me keep that. What we want to do is we want to expect the. Do we have king? Let's expect the king. Take this out. Now let's actually leave that. This is crucial for testing. So we're going to expect the king to equal to attacker dot address. Sorry, no. Attacker contract dot address, right? Because our our attack contract should be the new king. So we're going to grab the price data. And let's actually not deploy this. Let's do one more thing. Let's grab the price data, or the prize data. We're going to and king data. Let old king equals await king contract dot king. And let's just see who this is. The old king is old king, and this should be Ethernaut owner. So to be go to attacker contract, it should be king. Actually, I don't even know who the owner of that is. So let's just comment this out for now and run this without deploying anything new. Attacker contract. We didn't deploy that. It's not a function. It's underscore king. got me. Okay, so this is going to be the old king, and that's going to change to the contract address. So let's make, do a few things. We're going to deploy our attacker contract, make sure that's deployed. And then we want to invoke our attack function with the prize value to become the king. So let transaction attack equals attacker contract dot attack. Right? Calling this attack function. And I should remember how to do this, but the value is going to be equal to ethers.parse or ethers.utils.parse ether, and we're going to send prize value in ETH. And I believe that's how we do it in Hardhat. Let me call a function. Or at least when we call a function with a value. So we go to home. Let's just say calling a function in Hardhat. I literally always search this up. But yeah, you do it inside of the message or the function. So we have this king. So we're going to parse ether. It's going to be that prize value in ETH, because remember, if we send the prize value, if our value is greater than or equal to the prize, then we're going to successfully invoke this receive function. And so what we're doing is attack is going to send the 0.001 ETH to this contract, which should invoke the receive. So we're going to see. It may fail. There may be a reason with why this fails, but this should be the case. So parse ether is going to send that 0.01. Don't need that, but we need a receipt. So let transaction receipt equals transaction attack dot wait and the transaction attack receipt is this here. We're going to look at that transaction receipt. So we want to know what happened during that transaction. And then, actually, okay, let's grab the transaction too. So we're going to invoke our attack function, and also we have to make sure we call await because it's an async function call. There's no need for any type of self-destruct or anything, but for point number 3, or our third part is we want to grab the new king contract, or sorry, the new king. Okay. Excuse me. All right. King is going to be equal to await king contract dot king. The new king is excuse me. Excuse me. All right. This should be our attacker contract address. And just to verify, or actually no, we'll do this in our check here. Check if our contract is new king. We're going to say expect the king to be the attacker contract address. And if this test passes, then we know we have a successful exploit, because our new contract, our attacker contract address cannot receive any ETH at all via a transfer function. And we know this because we actually just tried to transfer, and we confirmed it on Etherscan. So let us try and commit this full exploit. Let's rerun through this because sometimes we make mistakes. So we have king exploit using attack contract. We have a setup for attack. So first we want to get an attacker address. We don't really need this, but I just keep it in my templates. The contract address, this is the address of the deployed. This is the address of the deployed king contract right here. We're going to deploy our own attacker contract, which is going to commit the attack. Then we're going to make sure it's deployed. And then we're going to grab our king contract. We're going to begin our exploit. So let's grab this price, or the prize. We're going to make sure we convert that to a value in ETH, so that whenever we send the transaction, we'll know how much we need to send exactly to start this exploit. Then we're going to invoke our own attack function. So what this is going to do is send 0.001 ETH to our attack contract, which is then going to send this 0.001 ETH to the king address. Okay. And what's going to happen is it's going to invoke this receive, and it should become the new king. All right. We're going to wait for this transaction. We'll print this out just so we can see some details about that transaction. And then next, we're going to grab the new king and log it to the console. So this should be the deployed contract address. And to verify, we can say log to the console and log the attacker contract to the console. Just so that we can see, like this test is going to verify that, you know, our new king address is equal to our attacker contract address, but we want to just go ahead and see that ourselves. The attacker contract address is, and let's say attacker contract dot address. All right. This is just so that we know, we see this. So I think this exploit should work. We're going to see if we run into any issues. Maybe we've forgotten a wait somewhere right here. Yeah, this is looking good. Let's go ahead and run this exploit. Let's watch it live. Okay, The old king is this. Next, we're going to make that transaction. Nice. The new king is this, and the attacker contract is this, so they became the new king. All right, so let's look at a few things. This is the transaction hash of the attack. We can go look at this on Etherscan. It went from my address to the attacker contract. This data should be the function that we invoked. So we could actually look at that because Solidity Visual Developer has a good way to see these. So let's look at the function signature. Yep. 9E5FAAFC. So that's the function we invoked. We know that. We don't really need to care about this, but so what happened? So we sent money to this address. This is just the logs, the block hash, the transaction hash, which should match here. B6, yep. Okay, and this is just the receipt. So confirmations, one confirmation, how much gas was spent, the whole nine. So we should have successfully completed this. Now the part of the actual, make sure this exploit works is submitting on Ethernaut. So when we submit this instance, what they're going to try to do is take back King's ship. And what's going to happen is they're not going to be able to because we successfully made a contract that blocks any transfers. So that's the theoretical problem. If they are able to take King's ship, then we're going to have to approach a new attack tomorrow. Submitting. Mine the transaction. Let's go. All right. So we successfully performed this exploit. And it is 9 o'clock. So I'm going to do some other studying on my own. But this is a great example of learning how kind of contracts work. You understand what happens when you transfer money to contracts, and then also you understand how do you prevent transfers from occurring in your contract. So we're going to go to the next level. We can do the next one tomorrow. Reentrancy, it's a prominent vulnerability we'll see in a lot of you'll see in a lot of contracts. I'm very excited for this one because I think this is going to be a tough one for me. But yeah, we'll tune in either tomorrow or sometime this week to do this one. As always, feel free to DM me on Twitter or on Telegram if you have any questions about any of these challenges, or just drop your comments in the video. Thanks, y'all.